Okay, let's look at 2b. So we are still graphing. It asks us to state the amplitude and period. So amplitude has to do with the number in front. So here it is positive, so we don't need to take the absolute value. That amplitude is 4. The period has to do with the number in front of the variable inside the trig function. Here it's a 3. So the period is always 2 pi divided by that number. So we have 2 pi divided by 3. That can't be simplified anymore, so that's the period. Now we will have a phase shift. Since this is inside of the parentheses, this plus pi means we will move to the side pi. A positive means left. A negative means right. So when we're drawing our graph, drawing the first period of the graph is not going to be where it normally is. It's going to be to the left pi. So when I draw my graph like this, I'm going to leave some room to go to the left by pi. So usually when we're drawing the first period, we start at 0. We draw the end of the period, which is 2 pi over 3. Divide that in half, so it's multiplying the denominator by 2. Which would cancel the 2 out top. So it's just pi over 3, 2 pi over 3. Half of that is just pi over 3. And then half of pi over 3 is pi over 6. And then to get that missing measurement right there, you add pi over 6 and pi over 3. When you do that, you can see the previous video for exactly how that happens, but when you add those fractions, you're going to get a pi over 2. So those are each pi over 6 increments apart. So in between 0 and pi over 6 is pi over 6, in between pi over 6 and pi over 3 is pi over 6, in between pi over 3 and pi over 2 is pi over 6, and so on. You get the picture. Okay. So before we do anything with the patterns or anything, this phase shift is tricky because we need to move to the left pi. So what I do is, it's not as clear on this one. So what I did is I drew my graph out a little bit to the side. And if we added pi over 6 to 2 pi over 3, you'd get 5 pi over 6. And then if you added pi over 6 again, you'd get pi. So if we are going to move everything to the left by pi, the one that is at 0 will the one that's at usually 0. Sorry, the one that is usually at 0. Okay, will now be at negative pi. Because that's moving to the left pi increments. The dot that will usually be at pi over 6 will now also move back pi, so it won't be quite at negative pi. So if we were going to take these increments over here and align them on the other side, this would be negative pi over 6 because it's a mirror image. And then we would have negative pi over 3. And then we would have negative pi over 2. And then we'd have negative 2 pi over 3. And then we'd have negative 5 pi over 6. So these are all going to be pi over 6 apart, and what's usually at 0 is going to be at negative pi. So that means my whole graph is going to fit on the other side. So my sign pattern starts with 0, then 1, then 0 and negative 1 and 0. And the y value changes happen at the amplitude and the vertical shift. There is no vertical shift, so it's only the amplitude. So all I need to do is multiply this by 4. So we have 0, 4, 0, negative 4, 0. So I'm going to put that on my x-axis here. So we have 1, 2, 3, 4, and negative 1, 2, 3, 4. So when I graph this, Instead of at 0, I need to go to the left pi, so that's back here at negative pi. So my 0 is going to start here. And then my next dot, which would normally be at pi over 6, will now be at negative 5 pi over 6. So that's 4, which is all the way up here. And then I'm coming back down to 0, then negative 4, and 0. And that is my entire graph once I connect all of these dots. And there we go.